Should I start? Hello, I'm Nabil from TechTalk. Welcome to our TechTalk sessions. Uh, Today I'm going to talk about some best practices that can help keep our code clean. My talk is based on two books that I had the opportunity to read in the last week. The Pragmatic Programmer by Andrew Hunt and David Thomas, and Clean Code by Robert C. Martin. For those who are experienced in this field, I'm just going to remind you about the general practices once more. And for those who are trying to or planning to be in the software engineering field, I just want to say try to get familiar with these practices early on. It might seem insignificant to you right now, but I'm sure that the experienced people present here will agree with me that the practices discussed here will save you a lot of time in the future. It is not possible to cover everything within this short talk. Therefore, I'm going to give you an overview of the best practices. For details, please refer to the books mentioned in the presentation. So let's begin. First, start with what is clean code. Well, here's a definition for you all. I'm giving you some time to read the definition. Can you guess who had given the definition? Well, it's from Baron Strausstrup, inventor of C++ programming language. Well, what happens if your code is not clean? Let me tell you a story. One broken window left unrepaired for any substantial length of time instills in the inhabitants of the building a sense of abandonment, a sense that the powers that be don't care about the building. So, another window gets broken, people start littering, graffiti appears, serious structural damage begins. In a relatively short space of time, the building becomes damaged beyond the owner's desire to fix it, and the sense of abandonment becomes reality. Consequences: clean functional systems deteriorate pretty quickly once windows start breaking. There are other factors that can contribute to software rot, but neglect accelerates the rot faster than any other factor. For those of you who are unfamiliar with the term software rot, here's a definition for you. When disorder increases in software, programmers call it software rot. So what are the steps that we should undertake to prevent broken windows? Well, rule number one, don't leave broken windows unrepaired. Here, broken windows means bad designs, wrong decisions, or poor code, and so on. Rule number two, fix each one as soon as it is discovered. And rule three is, if you find broken windows, then take some action to prevent further damage. As programmers, we should always use intention revealing names. Consider the two code snippet present here, and consider two programmers. The programmers at the left side initializes a variable, integer d, but the programmer didn't provide any description what the variable means. But he was generous enough that he has provided a comment and revealing the meaning of the variable. Elapsed time in days. D means elapsed time in days. But the programmer at the right side was generous enough to declare his variables elaborately, which exactly reveals the purpose of the variable. elapsed time in days. It exactly reveals the purpose. Similarly, integer days since creation, integer days since modification, while age in days all reveals the variable's purpose. So the code at the right side is good practice, and the code snippet or coding style at the left is bad practice. Hungarian notation. Let's consider two variables, integer a number and double the number. So what is Hungarian notation? Here the variable is declared as number and with a prefix of lowercase n, and the double the number with the number variable with prefix as a lowercase d. The style of declaring variables with lowercase alphabets, meaning they're the type of the variable. And this coding style is considered as Hungarian notation. Now please consider code snippet. Here you can see a member variable, private string m underscore this. Here the m underscore prefix means that it's a member variable. Now consider another code snippet. Here the variable is declared as this dot description. Nowadays we don't need to use Hungarian notation because we can do the same with the or achieve our purpose with this pointer. So the code at the left is, or the coding style at the left is obsolete, and the coding style at the right is correct. So you should always try to follow the current conventions, not the obsolete ones. As programmers, we should always give a careful thought of how function can be made small. You can see two functions on the screen. Here, both the functions are doing the same thing, but the function at the left is redundant, and the function at the right is pretty much small, but they are doing the same thing. So we should always careful about our functions. So the function declaring style at the left is bad practice, and the right is good practice. We should always try to avoid duplication. Most of the duplication we see falls into one of the following categories. One, imposed duplication. Next, inadvertent duplication, in-person duplication, and inter-developer duplication. Imposed duplication means when developers feel they have no choice, then it means that the duplication is imposed duplication. Inadvertent duplication means developers don't realize that they are duplicating information. And what is impression duplication? Developers get lazy and duplicate because it seems easier. Inter-developer duplication. Multiple people on a team or on different teams duplicate a piece of information. Let's consider an example. Here you can see that a variable is declared double length, but the developer is guilty of inadvertent duplication here because the length depends on two other points, the start point and the end point. So the developer at the right uh, use another line to describe that the length is dependent on the start and end point. So the coding style at the right is good practice, and the style at the left is bad practice. Well, about comments, here is a quote: "Don't comment bad code, rewrite it," by Brian Cunningham and PJ Plow. Here is a note for you. Comments do not make up for bad code. So always try to code well so that you don't need to provide comments. And your codes are self-explanatory. Consider another example. The programmer at the left uses a comment to describe what his code is doing by saying, check to see if the employee is eligible for full benefits. But the programmer at the right is somewhat stingy, and he didn't provide any comment because he didn't need to, because the code itself is self-explanatory. So you should always follow the good practice or good code style. Inexorable comments. Sometimes it's difficult to do without any comments. For example, consider the code snippet below. The programmer provides a comment saying that don't run unless you have some time to kill. It is a warning comment, which means that the code will take a very long time to run. So the programmer were warning the person who intend to run the code. Redundant comments. Here's an example you see of redundant comments. The first two lines are redundant comments because it's pretty obvious from the code below what the code is trying to do or what we should expect from the code. The code will throw exceptions. So the programmer shouldn't provide any comment here. That's why the comments are redundant here. Well, few practices are as odious as commenting out code. The codes are odious, commenting out codes are odious because others who see that commented out code won't have the courage to delete it because they will think it is there for a reason and is too important to delete. The last three lines of the code snippet shows commented out code. So you should always try to avoid this stuff. We'll now come to the vertical formatting. If you compare the two code snippets present here, you'll find that the code at the left is easier to read and easy to scan through, but the code at the right is somewhat jumbled. So the code at the left is good formatting, and the coding style at the right is an example of bad formatting style. We'll now come to the example of horizontal formatting. Let's consider another code snippet at the right. This code snippet is an example of bad formatting style. Why? You can easily understand if I present another code snippet at the left. The code snippet at the right is bad formatting because programmers often need to scan through the codes and find the variable what they're looking for. It's very difficult from the code snippet at the right, but it's pretty easier to find the variable that the programmer is trying to find or looking from the formatting presented at the left. So we should try to follow the good formatting, good horizontal formatting style. Okay, now come to train wrecks. The first line, the code here presents train wrecks. This kind of code is often called a train wreck because it looks like a bunch of coupled train cars. The functions, for example, get options, get scratch dir, get absolute path, these functions are chained with one another. So this coding style is considered as train wrecks, but it should always be avoided. Let me present you another code snippet below. If you ever need to change the functions, you should change the function like it is shown in the code snippet below. So the coding style or the code snippet below is good, and the code train wrecks is bad practice. Testing are a very important feature of coding. There are three laws of test-driven development. One, you may not write production code until you have written a failing unit test. Two, you may not write more tests than is sufficient to fail, and not compiling is failing. And the third law is you may not write more production code than is sufficient to pass the currently failing test. You should always try to remember these three laws of test-driven development, because tests makes our codes more robust. So you should always follow test-driven development. Clean tests follow five other rules that form the above acronym. First, the first point is fast. Tests should be fast, they should run quickly. When tests run slow, you won't want to run them frequently. If you don't run them frequently, you won't find problems early enough to fix them easily. You won't feel as free to clean up the code. Eventually, the code will begin to rot. Next, independent. Tests should not depend on each other, they should be independent. One test should not set up the conditions for the next test. You should be able to run each test independently and run the tests in any order you like. When tests depend on each other, then the first one to fail causes a cascade of downstream failures, making diagnosis difficult and hiding downstream defects. Repeatable. Tests should be repeatable in any environment. If your tests aren't repeatable in any environment, then you'll always have an excuse for why they fail. You'll also find yourself unable to run the tests when the environment isn't available. Self-validating. The test should have a Boolean output. Either they pass or fail. You should not have to read through a log file to tell whether the test passed. Timely. The tests need to be written in a timely fashion. Tests should be written just before the production code that makes them pass. If you write tests after the production code, then you may find the production code to be hard to test. You may decide that some production code is too hard to test. Well, the summary is try to follow the general coding convention so that your software is bug free, which is very important point. And prevent software rot by keeping your code clean. Here is the two references that I use. The Pragmatic Programmer by Andrew Hunt and David Thomas, and Clean Code by Robert C. Martin. Well, that's enough for this tech talk. Hope to see you in any future talks. Goodbye.